Hello and welcome back. This will be the third and final video on section 1.3. The first thing that I want to do here before we look at some more word problems is reminding ourselves of some formulas. So these will be formulas from geometry, and they'll be for area, perimeter, and volume of different shapes. So for a square will have the same side lengths on both sides, and all of these angles are right angles. They'll all be at 90 degrees. The area, we'll just take the side lengths and multiply them together. So we just have s squared, hence y is associated with a square. And then the perimeter, we have 4 side lengths that are all the same. So the perimeter is simply going to be 4s. For a rectangle, this book uses width, so a W to represent the height of the rectangle, and an L, so script L, for the length. So the area is just going to be the width times the length. In fact, they normally write the length times width. The perimeter, so again, this is just the distance around the rectangle. There are 2 lengths and 2 widths. So the entire way around will just be 2L plus 2W. The circle is just defined by one measurement, which will be the radius, which I'll use an R for. And the area of a circle is going to be pi times r squared. Pi is approximately 3.14, and then we'll square r. The perimeter is going to be 2 pi r. These formulas look fairly similar, but they are in fact different, so do be careful. With a triangle, we won't look at the perimeter of the triangle, but we will look at the area. And the way that we'll break this triangle up is we will have a length that goes straight up and down, and we'll call this the height. And this should be at a 90-degree angle with this bottom, so we'll just lay the triangle down. And this we will call B for the base of the triangle. And the area of the triangle will be 1/2 the base length will be times the height. A trapezoid, which is also called a trapezium in other parts of the world, is a shape. Will have 4 sides. 2 of those sides are going to be parallel. So the top and the bottom run parallel with each other. The other 2 sides, will just connect them up. And again, the way that this will work, we'll have 1 length on the bottom and 1 length on the top. The book uses A for the bottom length, and it uses B for the top length. And we also need to know the height. Let me do this with a dashed line. We also need the height. And the area of the trapezoid is going to be 1/2 the height times the sum of the base lengths, as in the sum of the base and the top lengths. So these are all 2-dimensional objects. For 3-dimensional objects, we can calculate the volume. A cube is going to have the same length in all 3 directions, and the volume is just going to be s cubed, s to the 3rd power. Sort of a variation of the cube, we can stretch it in various directions, and we can come up with what the book calls a rectangular solid. I've often heard this referred to as a rectangular prism. And to give these names, so we'll have 3 different directions in here. You have a width, a length, and a height. And then the volume is simply going to be the product of these 3. So they write the length times the width times the height. For a circular cylinder, so again, we just have a circle, and I can draw sort of the background of this. So it's like a can of soup as a circular cylinder. And we'll have two measurements for this one. We'll have the radius of the circle that defines this, but also the height of the cylinder. And the volume here is going to be pi r squared, which you'll recognize as the area of the circle, times the height. And then we have two more to look at, the sphere and a cone. And then the sphere, so again, I can sort of put that back, a loop in there. Again, there's only one measurement that'll define the sphere, which is going to be the radius from the center to the outside. And the volume will be 4/3 pi r cubed. And the cone will be somewhat similar. So the cone, again, will have this measurement here, which I'll call r, and the height from that center of the circle to the top, which will be h. And the volume of a cone is going to be 1/3 pi r squared height. So you recognize this inside bit as the volume of this circle times the height, but we're going to have to multiply it by a factor of 1/3 since it's not quite a cylinder. So with that in mind, we can answer some questions about geometry. So for instance here, we have the length of a rectangular basketball court is 44 feet more than its width. So it's longer than it is wide. If the perimeter of the basketball court is 288, what are its dimensions? So we're trying to figure out what the width and what the length of the basketball court is. So again, if we have a rectangle, we will have the length and the width. And we know that the perimeter is just going to be twice the amount of the length, one for both sides, plus twice the width, because we'll have to travel both on both sides. So the perimeter, the entire distance around, is going to be this. So we have this formula already. So this is the perimeter. But we know that the length of the basketball court is 44 feet more than the width. So the way that I'll write this down is that if you take the width and add 44 to it, we should just get the length. Again, the length is going to be the width plus a little bit. How much bigger? It's 44 feet bigger. So we have these two formulas, and since the length is equal to the width plus 44, anytime I see an L, I can replace it with this expression. So the perimeter, I know that's going to be 2 times the length, but here we know that the length is just W plus 44 plus 2W. And we also know that the perimeter is 288 feet. So this perimeter is just 288. It's going to be 2 times W plus 44 plus 2W. So this is fairly straightforward. We can now distribute and solve for the width. The left-hand side can't be simplified. The right-hand side I can distribute 2W plus 88 plus the last 2W. I can combine like terms. 2W and 2W will be 4W plus 88. But I want to isolate the W by itself, so I'm going to subtract 88 from both sides to be left with 4W be equal to 200. And this is pretty simple. I want to divide both sides by 4 to get W should be equal to 50. So W is the width of the court, and that is 50 feet. But our original question asked for all of the dimensions, not just the width. So the length is 44 feet more than the width, as in L is going to be W plus 44. So if I need to know the length, that's going to be W plus 44. Well, W is just 50. So 50 plus 44 will be 94 feet. So this is, again, fairly straightforward. I think the hardest part here is just going to be setting up the original equations, making sure that we know the formula for the perimeter, and making sure that we know that if the length is 44 feet more than the width, we can write this equation down. The very last thing to mention in this chapter is just looking at some vocabulary, what something means. So when I say I'm going to solve a formula for a variable, this means that I want to rewrite the formula so I can isolate the variable on one side. So coming back to our previous example, we had the perimeter is of a rectangle is twice the length plus twice the width. So let's try solving this for W. We don't know what W is, we don't know what P is, we don't know what L is, but that doesn't matter. We're going to solve for W by getting it by itself. So for the moment, W's on this side, there's an L on that side as well. So I don't want that over there. So I'm going to subtract 2L from both sides of the equation so that I have P minus 2L. The 2L and 2L will cancel out. I'll just be left with 2W. Next, I have 2 times W. I don't want 2 times W. I just want W. So I'll divide both sides by 2, and I'll get P minus 2L divided by 2 is equal to W. Notice I have W by itself on one side of the equation, so therefore I have solved this equation, this formula, for W. Now, if I knew what P and L were, I could just plug them in and get W without having to do much rearranging. This is the power of solving for a variable. So let's look at one more. So here we have P is equal to C plus MC. I'm not sure where this formula comes from in the book. This is just an example of a formula that they give us. And they want us to solve for C. So we have to get C by itself. And C shows up here twice. So the first thing that I want to do is make it so that there's only one C in here. So there's no C's on the left-hand side, so I don't have to do anything that. So what I'll do is I'll factor C out. So if I pull a C out, this first thing is going to be C times 1, and the second is C times M. So if we look at this, I've pulled a factor of C out of both of these terms. Likewise, if I just wanted to check, I could distribute C, and we'll see that we actually get the same thing. So these equations are equivalent to one another. And from here, this is fairly straightforward. I have a factor of C and a factor of 1 plus M. I need to get rid of that factor of 1 plus M. So what I'll do is I'll divide both sides by 1 plus M. These cancel, and I'm left with C on the right-hand side will be equal to P over 1 plus M. So for me, this is the easiest, the simplest way to solve for C here. I'll factor it out and then get it by itself. So this is my equation solved for C.